My name's Ryan,
And I'm Myron.
and welcome back to our YouTube channel. So today we're going over Opti 380 Lab 7 report, which was Michelson Interferometry Part 2, our TA being Harsha Pradeep, and we are lab section Tuesday 2 to 5. So to begin with, here's a little overview of what we did. So Part A was calibration of our interferometer, using the laser to align the two images from the mirrors and then find a calibration factor. Part B was using that calibration factor to find the wavelengths of different sources, and Part C was finding the separation of a sodium doublet, which was measuring distance between nulls. So here's a little bit of background of what a Michelson interferometry is. All it is a laser that's being split by a beam splitter, being reflected back to that beam splitter using two mirrors, and then you are able to observe interference on an image plane where there's a change in optical path distance. And then, so here's part A where we calibrated our interferometer. So all we did was adjust the height of the laser or the tip tilt of the mirror so that the images from mirror 1 and mirror 2 are overlapped on top of each other. And then once we did that, we found the calibration factor by moving the micrometer and counting 100 fringes, and then using that equation on the screen is how we found calibration factor.
For part B, we measured the wavelength of three different sources. We did this by aligning the interferometer as done in part A, but this time only counted 50 fringes and measured the distance the micrometer moved. Using the same equation we used in part A, but rearranging the variables, we solved for wavelength, and for the laser we got 632.8 nanometers, for mercury we got 610, and for sodium we got 627, which are all relatively close to the theoretical values. Going on in part C, we measured the separation of a sodium doublet using this by aligning the interferometer as done in part A, but this time moving the micrometer all the way to the end of the scale, which was at 0, and observing three nulls. And we measured the distance between three different nulls and took the average using the equation on the screen to calculate the separation, which we got to be 0.5 nanometers, which is very close to the theoretical value of 0.59 nanometers. In summary, we in part A, we used a laser to measure the calibration factor of our micrometer to be 21.3. Using that calibration factor in part B, we measured the wavelength of all three sources, and then in part C, we measured the sodium doublet separation by identifying nulls. Possible sources of error include inaccuracy in calibration factor from part A, miscounting the number of fringes, our interferometer not being aligned, or inaccuracies in finding the exact position of nulls in part C.
That was our Lab 7 report. Thank you for listening.